All right, welcome to the lecture. 2.5 hours on the clock. We are continuing with cancer and then popping into the next one, which was labeled Chapter 4 and a couple of pages originally. Might be a little bit more than that, though. Where we left off was with carcinogens. Brief review. Carcinogens were anything that can damage DNA or cause mutations. Anytime you damage DNA, it must be repaired. Anytime it gets repaired, there's a chance that it fucks up and causes a mutation. And then there are substances that may directly cause mutation. So, radiation damages DNA, comes in two flavors, ionizing and non-ionizing. With either one, the more you're exposed to it, the more dangerous it is. This is a cumulative lifetime exposure thing. The more exposure you have over time, the more likely you are over time to get one of those cancerous mutations. And that's because over time, you're continually damaging DNA. All right. Ionizing radiation, things like X-rays, nuclear fuel, radon gas. Radon gas is relatively common in Colorado soils, just precipitates up. That's why most basements out here have a filter system in order to expel the gas out of the basement. X-rays, while ionizing radiation, are not exactly horrifically dangerous, right? If you get 2 maximum strength CAT scans, that represents a cumulative 0.1% increased chance of cancer over your entire lifetime. One lower gastrointestinal X-ray is like 0.04%, right? A mammogram is 0.002% increased chance. So, when talking about your increased chances of getting cancer, you got to remember you start with a 20 to 25%. So that's just from being alive on this planet because of background radiation, right? Just living on the planet exposes you to background radiation and age. So you've already got a 20 to 25%, so I would not exactly skip out on medical care just because of the ionizing radiation involved, because for all intents and purposes, it's pretty much safe. Non-ionizing radiation is ultraviolet. So, our biggest cancer danger here is skin cancer, right? The skin is your defense against harmful radiation from the sun. As I said in class, melanin protects you, deflects ultraviolet radiation. But too much exposure leads to a burn. Constantly exposing yourself to it for, say, maintaining a tan increases your chances of getting cancer. So my recipe for success is to stay pasty and don't tan. But, you know, for what it's worth, don't go to like tanning salons that just directly expose you to UV radiation to get the tan. That seems just terrible, biologically speaking. So, and when you're out in high sunlight, always use your sunscreen. Okay, continuing on with carcinogens. Tobacco smoke itself is a carcinogen. So we were talking about smoking and the dangers it causes as a lifestyle risk for cancer. Well, in tobacco smoke, basically the product of what you get when you burn a cigarette are 60 to 70 different mutagenic chemicals. So that sucks. Then there's other pollutants. Things you get exposed to via skin contact, ingestion, or inhalation, right? These can include things like metals, such as asbestos. Asbestos is a mineral metal. You can actually find it naturally, which is why it was inexpensive back in the day. And it's also really good at being a fire retardant, which is why it was used back in the day. But asbestos as a mineral can flake and break down, and it creates teeny tiny little particles. Those particles get into when you inhale asbestos particulates, they damage your tissue, and anytime they damage your tissue, you can have repair fuck-ups. And because asbestos produces so many fine particles, it's dangerous. You can also have organic pollutants. Benzene is an industrial chemical that can cause cancer. There are a number of industrial or agricultural compounds useful, but carcinogens, when they are contacted via skin, ingestion, or inhalation. This is another cumulative lifetime risk thing. So, as the products plainly state, use protective gear. Definitely use protective gear. So, irritants are inhaled particulates. So, extremely fine particles that are inhaled that can cause direct damage or may provoke an inflammation reaction. Either way, they result in damage. And they increase your risk of cancer, specifically oral, throat, and lung cancer. So, regular damage from inhaled irritants increases your risk. So, again, wear protective gear when dealing with anything like that. So, hardware chemicals, pesticides, herbicides, these are all things that are dangerous to be exposed to. So, they all recommend you wear protective gear. Do that. And then, don't drink or huff them also. Not to get all judgy. A list of known carcinogens. Everything you eat, everything you breathe, everything else. Seems about right. Okay. Next up in the carcinogens are viruses. Next up in the things that can cause cancer. So some viruses cause mutations in their cellular hosts. So if this is your body cell going, oh, I'm having a good time. I want to see my plug collection. And then a virus comes in and gets into the cell, releases its genetic information, and starts getting its genetic information read. A byproduct of that infection could cause a mutation in the cell. So hepatitis B and C are great at mutating cells. A virus called Epstein-Barr virus and human papilloma virus. So Epstein-Barr, Epstein dash B-A-R-R. That's Epstein-Barr virus. And then human papilloma virus, or HPV. So hepatitis B increases your risk of liver cancer, actually, which is fascinating. Good news, though, is that it's protected against with the Hep A and B vaccine. So get your vaccines to protect from a cancer-causing hepatitis. HPV increases your risk of cervical cancer. So it doesn't do a lot in men, but in women, certain strains of HPV, and you can never be sure which strain you're infected with, can increase your risk of cervical cancer. So the good news is that there's that Gardasil vaccine that went to market that is able to protect from a large number of the strains that most commonly cause cervical cancer. Is it 100% protection? No. Viruses are champions of mutation. So there are always new strains appearing, but it offers significant protection that you would otherwise not get. So get your Gardasil vaccine. And finally, Epstein-Barr virus increases your risk of lymphoma, for which there is no vaccine. There's no vaccine for Epstein-Barr virus. So that sucks. Lymphoma, if we recall, was cancer of the lymphatic system. That series of vessels that run alongside your blood vessels and carry water from all your tissues back to your bloodstream and are where the lymph nodes are found. So Epstein-Barr virus can get in there and can mutate cells in the lymph nodes and cause lymphatic cancer, lymphoma. It blows. So now that I've depressed you with all these things that cause cancer, let's talk about your natural defenses against cancer. First off, our defenses in your own genetic code. We have what are called tumor suppressor genes. Tumor suppressor genes, right? So the tumor suppressor genes are all about controlling the cellular defenses against against cancer. So they basically help produce a lot of your natural defenses. Before a tumor can grow, it must make it past all your body's natural defenses against cancers. And the very basic of all of this are the tumor suppressor genes. Both alleles for your tumor suppressor genes must be mutated in order to malfunction. So it provides you significant protection. These genes have their fingers in everything. The cells can remove and repair mutations that occur as the result of repairing damage. Cells can also repress their own growth factor response. And cells can repress the growth factor response of other cells around them and promote apoptosis. They can cause cell death, right? So your cells in and of themselves can fight the mutations that may cause them to become cancerous, and the cells around them can suppress their growth and promote apoptosis in the cancerous mutations. So that's pretty good off the bat, and then we add the immune system into it. Your immune system recognizes 10 million plus cancer signs. So your immune system recognizes cancer pretty effectively. This means that when a cancerous cell is detected by the immune system, it acts to prevent growth and kill cancerous cells. More than that, if you develop new cancers, your immune system can become sensitive to those cancers and recognize them and then act to prevent cellular growth and kill the cancerous cells. Right? Your own skin right there has melanin in it to block UV radiation, and your skin happens to be watertight, which means pollutants don't pass straight through your skin into your bloodstream, which is nice. Even your own mucus is a way to protect against cancer. So, for instance, pathogens like viruses that may cause cancer have to deal with your mucus layers. The mucus traps up pathogens, and then immune cells kill them where they're trapped up. So it provides a barrier to further infection. So your immune system is pretty amazing. Between skin, the mucus, and your, T cells, you have these T cells, killer T cells. And they possess some cancer recognition stuff. And one of the things they secrete is something called TNF-alpha. So tumor necrosis factor, TNF-alpha. It's literally a chemical secreted by a T cell that kills tumors. Pretty amazing. It sucks that there are, of course, cancers that get past the immune system or overwhelm the immune response. But it's amazing to think that there are natural cancers to which you're exposed that you develop immunity against, or at least you're not immunity against, but your body can recognize and fight them. So mucus traps them, and then the immune system acts against the pathogens there. So anyway, here's just a quick little picture, right? Here's tumor cells. Here's those killer T cells coming in, and they'll secrete chemicals to try and kill it. So pretty cool. Just a nice little picture there. And this gets us to treating cancer. So there's some traditional treatments. The most basic one is surgery, right? When you do surgery, you remove tumors. So what they'll do is they'll go in where they know a cancerous tumor is. They'll cut out the cancerous tumor. They'll cut out the surrounding tissue. And they'll usually take some of the lymph nodes from the area in order to detect if the cancer spread through there. So surgery is all about removing the tumor and the tissue around it, which may or may not be cancerous. So just straight trying to cut it out. Now, obviously, when you have individual cancerous cells that may be spreading through your bloodstream, you cannot guarantee surgery will take out everything. So that's why we then have radiation. Radiation therapy can kill the cancerous cells. So radiation creates sort of a toxic environment, a weakened environment. And then you add in chemotherapy. Chemotherapy is a chemical cocktail of various drugs that are tailor-made to kill cancer cells. They kill cancer cells. They can inhibit replication. They can starve those cancer cells of nutrients. They can disrupt the membranes of cancerous cells, breaking the membrane open and killing the cell. They can damage the cancer cells themselves, damaging the cell, damaging the cell's DNA, and when you do that, you inhibit the repair mechanism as well. So if you can damage the cancerous cell DNA and inhibit the DNA repair, you kill the cells. So as I said, these are tailored to specific cancers, and they can be extremely effective. The most common childhood leukemia has a survival rate of 80% now due to the effectiveness of modern chemotherapy. 80% survival rate in childhood leukemia. If you catch Hodgkin's lymphoma in stages 1 and 2, then you have a 90 to 95% survival rate. So our chemotherapy drugs are always getting better, and they are pretty amazing on their own. The downside, of course, is that in order to target cancer, what they really do, they have, some specific chemicals that will target cancerous cells, but they also target any fast replicating cell. So bone marrow cells can be damaged by chemotherapy. Hair growth gets inhibited by chemotherapy because your hair follicles grow quickly, right? These all replicate quickly as normal. So you get a loss of hair when you get a reduced bone marrow count, bone marrow mass. Remember when I was talking about those stem cells that can produce multiple different types of cells? I talked about the hematopoietic stem cell. It produces red blood cells and white blood cells, and they exist in the bone marrow. So when chemotherapy attacks cancers, and as a byproduct attacks your bone marrow. It drops your red blood cell count, and it lowers your white blood cell count. This is why people in chemotherapy become immunocompromised. Their immune system is compromised because your bone marrow is a byproduct, is damaged in the byproduct of treating your cancer. You get a reduced red blood cell count, lower activity, lower energy, and you get a reduced white blood cell count, which is reduced immune system activity. This can make you more susceptible to infection. This is why vaccination is so important. When we vaccinate, we protect not only ourselves, but the people around us from pathogens. So infants, cancer patients, the elderly, they're all susceptible to pathogens, more so than a regular healthy adult, because our immune systems, us regular healthy adults, are functioning full throttle. Someone on chemotherapy has a lower white blood cell count, has reduced immune system effectiveness, and so they're more susceptible to pathogens, and when they get infections, their infections are worse. So more likely to get worse side effects or effects as far as the pathogen's concerned. Anyway, so these are the 3 standard treatments. And now we'll go into immunotherapy. Immunotherapy is the concept of using your body's own systems to help fight it. And we do a lot of genetic engineering in immunotherapy. So there are 2 basic ones I'll talk about. One is the P53 gene. So the P53 gene is pretty cool. In a normal cell, the P53 gene seems to have no effect. So the question is, why on earth would that be useful in treating cancer? Well, the P53 gene is absent in cancerous cells. And when we genetically engineer it, when we take a virus that inserts DNA into cells, we can put a P53 gene in there. We'll take out all the viral genes. We'll pop in a P53 gene. And if we give that virus, some cancer cells, and it injects its P53 gene into there, and the cancer cells pick up the P53 gene, then they die. That's right. P53 gene is absent in cancer cells. In normal cells, it has no effect, and when you add it to a cancerous cell, apoptosis occurs. So the way to add it is through engineered viruses. We remove the viral genome, the viral genetic information, say, nope, none of that. We don't want you to cause an actual disease, an infection. We're giving you a P53 gene. You deliver that for us. Another cool one is the lentivirus treatment. So lentivirus vectors are really useful in treating or in genetic engineering, especially for cancers of the white blood cells. So lentiviruses, their most well-known ambassador, of course, is HIV. Human immunodeficiency virus belongs to a class called lentiviruses. It likes to roll up into your body, attach itself to a white blood cell, inject its HIV genes into you, and then the HIV genes are added to the white blood cell's own DNA. And then there's no way to get rid of it. It's incorporated in, it becomes a natural part of that DNA. Really blows. Makes HIV very hard to treat. But as a vector for delivering genetic information for genetic engineering, lentiviruses are pretty cool. The first thing you do is, of course, remove the HIV genome. You don't want any of those infectious genes in there, and we can do that. So if someone has a cancer that the immune system can't recognize, you can craft some genes that would allow immune cells to recognize the cancerous cells, right? And you pop those into the lentivirus so that it'll put those genes for recognizing the cancer cells in, right? Then you need enough of those genetically engineered immune cells to take care of the problem, because it's almost impossible to, handle the entire immune system through lentivirus vectors. Much easier to also, in addition to having genes that recognize the cancer you want the immune system to treat, you put in genes that allow those immune cells to replicate, to increase immune cell replication rate, right? So once you put in genes for recognizing the cancer and genes that will allow those engineered immune cells to replicate quickly, pop it into the HIV virus, pop it into the patient, and it inserts those genes into the immune cells. This is pretty cool. It's very new research, and it seems to be very promising. It effectively kills cancer. In what limited tests we've done, it's very good at killing cancer. It's time intensive, it's resource intensive. You've got to find the genetic markers that will work to get the immune system to key in on a patient's cancer. Then you've got to add the correct genes in there, right? So for any single patient, it's a highly tailored, highly time-intensive treatment. But it's cool because it seems to work very well. Don't know dangerous doses yet. We don't know side effects. For instance, when the genes get added in, like when HIV plops those engineered genes into the immune cell, it's potentially possible, because it has to, here's my genes, and I want to add it in, right? It's got to open up the genome and then add the genes in and close it back up. That's what it does. Opens, adds, and closes. All right? So what happens if it opens it in the wrong spot? That could happen. So we need more research with this. But it's very cool how promising it is. I love this comic. Okay, so blood cells growing out of control. Cancer. So you're going to give me different blood cells that also grow out of control? The engineered white blood cells. Yes, but it's okay because we've treated this blood with HIV. Are you sure you're a doctor? Almost definitely. So, vector inserts the genes, and it is very promising, but it's very early stage. So this is not a treatment you're going to see commonly. This is for in the scientific experiment territory. All right, here we go. Just a little thing of therapies, right? Surgery to remove the tumor. Radiation to kill dividing cells. Chemotherapy to kill the rapid growing cells, right? Part of chemotherapy is inhibitory drugs to stop blood vessel growth, inhibitory drugs to prevent the tumor from releasing cells. There's the p53 gene. And then cancer vaccines, which are being developed. Pretty cool. All right, next up, danger signs. Or as I like to call it, the part of the lecture where you all diagnose yourselves with cancer. So, here are some danger signs that mean you may want to go have a talk with your doctor. Unusual bleeding or discharge. So, unusual bleeding or discharge. Bad signs. Whether or not that's cancer, who knows? But if you've got unusual bleeding and discharge, maybe see a doctor. New lumps or sudden thickening of tissues. That indicates that there's new tissue growth. Tissue is growing. You might want to get that checked out to make sure it's not a tumor. Sores that do not heal. Non-healing sores. Again, cause for worry, go to the doctor. Here's one of those ones I like. Unusual changes in your bowel or urinary functions. So here's one of those ones where you can all diagnose yourselves with cancer, right? Not, I ate something that didn't agree with me, but now I've got cancer. Anyway, this is more like sudden, unusual, unexplained changes. Again, unexplained, unusual hoarseness or cough could be indicative of something wrong with the respiratory system. Mole and wart growth, specifically changes in size and especially changes in the margin. So if you look at my mouse, the mouse is moving around the margin of this mole. Most moles have a pretty regular, smooth margin. It's not going to be a perfect circle around anything, but just looking at my moles, if I get in there close, it's a regular margin. If you get a new mole growth or the margin becomes highly irregular, something's happening. Something's growing. Get it checked out. And then finally, unexplained and unusual difficulty swallowing or digesting could be indicative of cancers of the digestive tract, esophagus, stomach, bowels. So, unexplained, unusual difficulty swallowing or digesting. So, one more time, unusual bleeding or discharge, lumps or thickening of tissues, non-healing sores, unusual changes in your bowel or urinary functions, unexplained or unusual hoarseness and cough, changes in size and margins of moles and sudden wart growth, and unexplained and unusual difficulty swallowing or digesting. These are all signs that maybe make you want to go see a doctor. Next up, countermeasures, how to protect yourself from cancer. Well, 75% of that risk, that cumulative lifetime risk of cancer, is due to lifestyle factors, right? So those lifestyle predisposing factors, things you have control of, that 20 to 25% risk is governed in large part by those. So let's see some of those things you can do. Avoid direct sunlight or protect yourself from direct sunlight with good old sunscreen. Quit smoking. Seriously, quit smoking. Like, if you gotta use a vape to bring yourself down off the cigarettes, go for it. But quit smoking cigarettes. If since this is Colorado, edibles are a better way to get your weed than smoking joints. So go for the edibles. Just be careful about dosage with that shit. Anyway, early detection. See your doctor. So engage in all that beautiful preventative medicine stuff that we have access to for now. This lecture may be less useful after the 4th of July recess in Congress. Anyway, that bullet point only. Still, avoid direct sunlight, protect yourself with sunscreen, quit smoking. Early detection. Take advantage of your doctor. And then, of course, one of the biggest things you can do to prevent cancer is to stop aging. Ha ha! Just a simple suggestion, right? So this is because as you grow older, your rate of replication errors and your rate of repair errors increase. So anytime your DNA is copied off, like during mitosis or meiosis, there's increased risk of errors. And anytime your DNA is repaired after damage, there's increased risk of errors. That risk goes up as you get older. As you get older, your cells start to experience more damage, more disrepair over time. As you get older, your immune system starts to function less effectively. It becomes depressed. And of course, as you get older, you are dealing with that cumulative lifetime exposure factor. So, if you could just stop aging, just engage in a little bit of immortality, who cares? So basically, when you're elderly, you're going to die of cancer or heart disease. Your lifestyle issues catch up to you. They catch up to all of us as we age. So make good lifestyle choices. Don't smoke. See your doctor. And try not to think about dying when you get older. Puppies! I'm just going to leave this up here for a second. Fucking cancer. I'm getting old. I'm going to die. I hate that. God.